Hi, my name is Thiago Pinto. I'm a PhD student of soil science from the Federal University of Jequitinhonha and Mucuri Valleys, UFVGM, in Diamantina, Minas Gerais. I'm going to talk the tropical mountain Peatlands in the Serra do Espinhaço Meridional region. I would like to thank you, Julie, for the invitation, Ingrid, my advisor, Alexandre, my co-advisor, and Diego, the postdoc researcher that helped me with this presentation. I'm going to start talking about the tropical peatlands around the world, present our research area, our group, and then I'm going to focus on CIMA, my PhD project. When we talk about peatlands worldwide, what we saw is the main concentration in the boreal area. But when we saw 4.23 million square meters around the world, and South America with 11.5% of this area, we see that the tropical peatlands are really important. But they are important not just because the carbon stocks, but also, and especially in the Serra do Espinhaço Meridional, they are important because the water reservoir of the rivers, especially in the dry season, there are many people living around these rivers that need this water. So that's the reason we need to protect these areas. When we look at this International Peat Society map from 2008, the distribution of Myers is concentrated also in the boreal region, but we have more information about the tropical areas in Africa, in Southeast Asia, and also in South America. When you take a special look, what we saw is the Amazon basin, the coastal plains, and the Pantanal basin regarding the main concentration of potential peatlands. The Serra do Espinhaço appears in a small region, but when we look at it, what is small? Small for the Serra do Espinhaço, it's around 800 miles from south to north, starting in Minas Gerais state and going to the north of Bahia. The word for Espinhaço, it's like a ridge, or just Espinhaço, spine, and Cordillera, it's the mountain range. But we're going to focus on this presentation especially in the southern Espinhaço Mountains. In 2005 was recognized by UNESCO the Serra do Espinhaço Biosphere Reserve, gathering a group of protected areas of the largest and most continuous Precambrian orogenic belt of Brazilian territory. There is a unique phytotaxonomy in the world on this region, the Rupestrum field, holding around 1,000 to 2,000 species, endemic species like from flora and fauna. But there is a small number of areas have been intensely inventoried. What we saw on these maps in brown, we have the São Francisco Basin, in light brown, the Jequitinhonha River Basin, and in blue, the Doce River Basin. But in red, what we saw, it's from 2013 to 2023, it's a huge increase in the potential area of peatlands in the Serra do Espinhaço Meridional, from 14 to 25,000 hectares. In a way to study the area, the Serra do Espinhaço Meridional, we focus on the Parque Estadual do Rio Preto, or Black River State Park, especially in the area of Chapada do Couto. It's 1,600 meters above sea level, and we have over there two important areas, two catchments, the Black River catchment and the Araçuaí River catchment. In red, we have the graded area outside the park, and in green we have the protected area inside the park. These areas have been studied since 2016, first with hydrologic parameters and now with many other researchers. Our group is composed by Alexandre Cristóforo Silva, ONU consultant and also the Long-Term Ecological Monitoring Program PELD leader. He's my thesis co-advisor. Together with Ingrid Horak Terra, she's a coordinator of two commissions of the Brazilian Soil Science Society and also the leader of Pedology and Paleopaisage Study Group. She is my thesis advisor. In 2020, we published a paper demonstrating that the colder climate of late Pleistocene limited the formation of peatlands above 1,570 meters above sea level in the Serra do Espinhaço Meridional. We based this information on several peatlands of the region. Most recently was published a paper by Ingrid reconstructing the climate regionally and locally based on 4 testimonials from peatlands. In blue we have the moisture, and in red we have the temperature. The core of our group needs to be mentioned with Diego Tassinari as the postdoc researcher, and also me. Yes, I'm a vet with a biosystem engineer master's degree, and now I'm a PhD student in soil conservation and soil management. About the hydrology from the last 2 years, what we saw is that the protected peatland in purple can hold water for longer periods and release this water with more effectiveness, different from the degraded peatland. Here is presented the name and the research line of several researchers of the PEAT program. Look at, we have not just physical participation, but also botanical and zoological representatives. Before I talk about CIMA, I need to present to you how I start to do this gas sampling. Yes, in 2021 I made 2 campaigns, 1 year after. Yeah, you know what happens. The best part of this is that I went to Rio, because this is the closest gas chromatographer that I found. So it's just around 600 kilometers to get there. I have 152 samples per campaign, and that took me 8 minutes per sample at the gas chromatography. So you can make the maths and find around 20-21 hours of hard work. As the result, what we had is, not so good. Just a few temperatures, a few points, a low level of confidence, but this made me go further and find a solution. As a solution, what I found is to build my own chamber that monitor environmental parameters and also the gas concentrations of CO2 and CH4. The name CIMA in Portuguese sounds better, but it's basically the Electronic Environmental Monitoring Chamber. And to do that, I went to Gothenburg University for a course, and they have 2 equipments. They have this box, this hard acrylic box with aluminum corners, and they have a light core and also a Uga Los Gatos equipment. Unfortunately, I don't have money for that, so I found in the Bast-Viken papers a smart solution. He used high cost efficient sensors to monitor the gas emissions, the greenhouse gas emissions in lakes in Sweden. So I'm kindly building something like that. At the moment, we are in the final part. We are using ESP32. This acrylic chamber is already made, and attached to that we have this Sensair K33LG for CO2, the Atlas Scientific for CO2, and Figaro, 2 Figaros for CH4. Also a humid sensor and a hobo for temperature and light. So I would like to thank you everybody for the time and attention in this presentation. Cheers. If you have questions, please make it. Thank you.